The night sky, for those pioneering astronomers who gaze upon it, is no longer merely a velvet curtain of deepest black, adorned with silent diamonds in repose, but rather a tumultuous arena where invisible titans roar, devouring matter and warping the very fabric of reality itself. And within this haunting cosmic symphony, the cry of a black hole, once deemed eternally mute in the vacuum of space, has for the first time echoed through humanity's receivers, a sound so terrifying that it has shaken the foundations of physics to their core. Envision that pivotal moment in August of the year 2022, when engineers at the Smithsonian Astrophysical Observatory and the National Aeronautics and Space Administration's Chandra X-ray Observatory were sifting through an immense dataset from a burst of X-rays following a tidal disruption event, a star torn asunder as it ventured into the gravitational clutches of a supermassive black hole located approximately 215 million light-years distant. This was an anticipated occurrence, a cataclysmic destruction foretold by gravitational theory. Yet what they captured extended beyond mere electromagnetic radiation. By employing intricate algorithms to convert the extreme pressure oscillations in the surrounding hot gas, propagated by shock waves through the plasma medium encircling the black hole, into frequencies audible to the human ear, a sound emerged from the void. It was not the screech of metal being sheared, nor the crash of collision. This sound, accelerated nearly 1 million times to fit within our auditory range, resembled a desperate wail, profound and lingering groan echoing from a bottomless abyss. It was the noise of absolute annihilation, an obituary for a star pulverized into its most fundamental particles. This event, formally documented as the detection of sound from a black hole via pressure waves in plasma, has ushered in a new era where we not only behold black holes but also perceive their ferocity. Recent advancements, such as those from the Chandra Observatory in September 2025, have further illuminated such phenomena by identifying a black hole exhibiting unprecedented growth rates, consuming matter at levels exceeding theoretical limits, thereby amplifying our understanding of these acoustic signatures through enhanced X-ray observations that reveal the violent turbulence in accretion processes. But this lament was merely the prelude to further physical nightmares. Accompanying this auditory revelation was confirmation of the most extreme temperature conditions ever observed. At the accretion disk, that swirling belt of matter spiraling towards the event horizon, the temperature is not simply hot but a cosmic fever reaching 1 billion degrees Kelvin. To grasp this frenzy, consider that the surface of our Sun is a comparatively mild 5,700 degrees Celsius. Thus, the edge of the black hole is hotter than our star's surface by 180,000 times. Matter there is fully ionized, transformed into a superheated plasma emitting X-rays and gamma rays of tremendous energy. Yet, mere millimeters away on the relative scale of the event horizon, lies the universe's ultimate chill, approaching absolute zero, a realm where thermal motion seems to halt entirely. This is what theoretical physicists term the Firewall paradox, a horrifying contradiction arising at the black hole's impassable boundary. Recent data from the James Webb Space Telescope in July 2025, identifying a possible direct collapse black hole embedded in ionized gas, adds depth to this paradox by suggesting that such extreme temperature gradients may facilitate rapid black hole formation in the early universe, where quantum effects could intensify the firewall's theoretical implications. This paradox stands as the starkest manifestation of the unending conflict between Einstein's general theory of relativity and quantum mechanics. According to general relativity, the event horizon is the point of no return. Once crossed, nothing, not even light, can escape, and one's fate is to be drawn inexorably towards the infinite singularity within. Should one fall into a black hole, classical theory predicts spaghettification, a horrific stretching due to the gravitational gradient, tearing the body into elongated strands like pasta. Quantum mechanics, however, insists that information cannot be destroyed. If one falls in, the information comprising one's being, from atoms to memories, must be preserved in some form. The Firewall paradox highlights this extreme schism. At the boundary, matter is incinerated instantaneously into pure energy, while quantum descriptions imply that the quantum state of matter is retained there, almost frozen. Observations from the Chandra Observatory in 2025, capturing a black hole's tremendous growth, underscore this tension by revealing plasma dynamics that challenge purely classical models, hinting at quantum influences in high-energy emissions. Even more shocking is that combining both theories yields two utterly divergent outcomes occurring simultaneously for a distant observer and the infalling individual. The external observer would see one decelerate upon approaching the event horizon, one's image redshifted infinitely by gravity until one appears frozen and fades, merging into the event horizon's scorching thermal radiation, incinerated to ash before their eyes without ever truly crossing the threshold. Conversely, for the infaller oneself, there might be only an initial mild jolt, if the black hole is sufficiently large to mitigate spaghettification, and one would traverse the event horizon in an instant, entering a region where time and space swap roles, hurtling towards the singularity where all current physical laws shatter. Both accounts hold true within their theoretical frameworks. This clash at the firewall is where physicists strive to forge a complete theory of quantum gravity, unifying all natural forces. Breakthroughs in 2025, such as the detection of the most massive black hole merger by gravitational wave observatories in July, provide empirical data to test these unified theories, with the merger's energy release, equivalent to 9 solar masses converted to waves, offering clues to quantum effects in extreme gravity. The year 2025 has witnessed an explosion of knowledge concerning these cosmic phantoms, not only in realms of extreme gravity but also in their isolation and cosmic homicides. In April of that year, the astronomical community was astounded by the official announcement of the first confirmed rogue black hole, detected not through its influence on nearby objects but via microlensing effects. Utilizing combined data from the James Webb Space Telescope and ground-based telescope networks tracking starlight distortions, scientists identified an object with a mass 7.15 times that of the Sun, drifting at an astonishing 51 kilometers per second through interstellar space. This is no supermassive black hole at a galaxy's core, nor part of a binary star system. It is a spectre, a primordial black hole, or perhaps the remnant of a massive star's collapse, wandering alone in the darkness for hundreds of millions of years. Complementing this, in November 2025, the discovery of a potential primordial black hole signal by gravitational wave detectors like LIGO and Virgo has suggested these ancient relics, formed shortly after the Big Bang, may exist in subsolar masses, further challenging population models and potentially linking to dark matter composition. This rogue discovery immediately reshaped models of black hole populations in the Milky Way. If one solitary object can be found, it implies our galaxy may harbor hundreds of millions, even billions, of non-interacting, non-luminous black holes without accretion disks, utterly invisible and silently traversing the voids between stars. We dwell amid a sea of gravitational traps hitherto unknown. The velocity of 51 km per second exceeds explanations by ordinary orbital motion. It suggests this black hole was ejected from an ancient binary system or a dense star cluster in the distant past, propelled by a collision or an asymmetric supernova explosion. Building on this, May 2025's revelation of dual massive black holes in a single galaxy, one stealthily orbiting the central supermassive one, indicates that such ejections and mergers are more common, potentially leading to future cataclysmic unions. Yet if the rogue black hole's discovery speaks of concealment, June 2025's finding offers direct evidence of spatial violence at its zenith, a cosmic murder captured through lingering traces. Scientists at Peking University, analyzing orbits of hypervelocity stars ejected from the Milky Way's center, traced a harrowing sequence from approximately 10 million years ago. They identified stars hurtling at extreme speeds, survivors flung like debris from an explosion. Kinematic analysis led back to the galactic center, home to Sagittarius A star, our supermassive black hole. The gruesome secret: Sagittarius A star once devoured another black hole. Data indicate an intermediate mass black hole, estimated at 15,000 solar masses, was drawn into the orbit of this 4.3 million solar mass behemoth. The ingestion was no gentle merger, it was a catastrophic collision. This event generated immense gravitational waves, ripples in spacetime that LIGO and Virgo have sought for years. Stars passing nearby endured frenzied gravitational forces, torn and accelerated to thousands of kilometers per second, becoming eternal wanderers bearing scars of the duel between two supreme entities. This is the first evidence that supermassive black holes may grow by preying upon and consuming their own kind. Echoing this, June's detection of a tightly packed cluster of supermassive black holes from 10.8 billion years ago reinforces the idea of hierarchical mergers driving black hole evolution. Also in June 2025, attention shifted to M87, the colossal supermassive black hole at the heart of the Messier 87 galaxy, an entity 6.5 billion times the Sun's mass, famed for the world's first event horizon image. A Chinese research team announced a discovery revolutionizing our view of the ultra-energetic jets these supermassive black holes expel. This jet of matter and energy, spanning 5,000 light-years, is not a steady, uniform flow as previously assumed. Instead, it performs a complex dance, cosmic waltz, recurring precisely every 11 years. Every 11-year cycle, the entire jet oscillates with a remarkable 10-degree amplitude. This wobble is no accident, it directly signals that the M87 black hole spins at extreme velocity, and crucially, its accretion disk, the superheated swirling matter layer, possesses far greater density and structure than prior theoretical models predicted. Of particular import, scientists link the jet's basal curved shape to the black hole spin dynamics. This knot-like structure reveals how intense gravitational and magnetic fields, intertwined with rapidly rotating matter, twist, flow lines, generating the mechanism to eject matter perpendicular to the disk at near-light speeds. This marks humanity's first observation of the precise dynamics of matter deformation and expulsion at relativistic velocities, unveiling the workings of the universe's mightiest engines. August 2025's observation of a waking, supermassive black hole, suddenly activating after dormancy, adds to this by showing how such jets can ignite abruptly, illuminating galaxy evolution. However, the universe's greatest enigma, intermediate mass black holes, bridging stellar and supermassive varieties, finally gained solid evidence in February 2025. For decades, scientists predicted these must exist, serving as building blocks for galactic center behemoths, yet detecting them proved exceedingly difficult, as they lack the strong signals of supermassives but are not obscured like smaller ones. A Chinese astronomy team achieved the improbable by focusing on tidal disruption events, or stellar shreddings, with a novel approach. As a star nears a black hole too closely, the gravitational force nearer exceeds that farther, creating devastating tidal forces. These rend the star into two, one portion ingested and devoured, the other hurled away at high velocity. This unleashes vast energy as X-rays and gamma rays over a brief period. Scientists analyzed periodic X-ray oscillations from observed disruptions. They discerned that these X-ray frequencies, or precisely the intervals between radiation bursts, correlate directly and uniquely with the perpetrator's mass. By decoding this fingerprint oscillation, they conclusively identified recent events as caused by black holes ranging from several hundred to several thousand solar masses. This ironclad proof opens doors to detailed studies of intermediate black hole accretion and growth. July 2025's joint Hubble-Chandra detection of an intermediate mass black hole devouring a star 450 million light-years away further validates this, providing visual and X-ray evidence of their destructive appetites. And if collision was June's theme, July brought gravitational wave power to new heights. The Laser Interferometer Gravitational Wave Observatory, alongside Virgo and Kagra partners, recorded the largest black hole merger ever detected. Two colossi, one 85 solar masses, the other 66, spiraled in a dance spanning billions of light-years. Upon merging, they birthed a new entity 142 solar masses. Astonishingly, 9 solar masses vanished from material existence, transmuted into pure energy as gravitational waves. The liberated energy equals the total output of all observable universe stars across their entire history, compressed into a cosmic blink. This merger occurred 17 billion light-years away, meaning its light and waves embarked when the universe was merely 6 billion years old. They traverse space and time, witnessing countless galaxies' births and deaths, the cosmos's expansion, before these faint waves brushed Earth, distorting LIGO's interferometer arms by a thousandth of an atom's width. This detection not only affirms general relativity's harshest predictions on mass loss in ultra-heavy systems but furnishes a novel tool for probing post-Big Bang conditions. July's confirmation of the most massive merger to date, producing a 225 solar mass black hole, amplifies this, with energy outputs challenging models of stellar evolution. Following gravitational wave breakthroughs, August 2025 delivered another shock regarding black hole formation and interactions, from deeper Shanghai Observatory signal analyses. Scientists noted that in certain dual black hole mergers, initial orbits appear non-random. Evidence suggests a third, vastly more massive entity intervened. Picture two small boats drifting slowly closer in a vast pond. Absent interference, they might drift eternally without contact. But introduce a colossal whirlpool at the pond center, and it draws both inexorably together, compelling collision. In the cosmos, this third supermassive black hole acts as the gravitational whirlpool. It does not join the final clash, but its field lures the smaller pair, adjusting orbits to ensure encounter and fusion. This discovery overhauls views on binary black hole evolution. They are not merely random pairs drawn together, they may be orchestrated by a third giant, a mechanism explaining observed diverse spins. November 2025's largest black hole flare, the biggest and most distant seen, ties into this by revealing how such third-party influences might trigger tidal disruptions on galactic scales. While these titans collide and wail, the profoundest philosophical queries about their existence are illuminated by quantum insights. The black hole information paradox, half-century conundrum, whether information truly vanishes forever upon entering a black hole, violating quantum mechanics' conservation principle, saw significant strides in 2025. Prior theory, rooted in Hawking radiation, posited black holes eventually evaporate, leaving random thermal radiation devoid of original matter's information. Yet latest studies in quantum field theory on curved spacetime, specifically extended string theory and loop quantum gravity models, propose a far subtler resolution. They suggest that at the event horizon's boundary, or even deeper near microscopic structures by the singularity, information is not lost but encoded intricately into spacetime's fundamental grains, persisting on a two-dimensional surface enveloping the black hole, reminiscent of the holographic principle. Even bolder proposals delve into interior quantum microstructure. Theoretical physicists introduced the quantum labyrinth, or quantum cube, within black holes. At the Planck scale, smaller than a proton by billions of trillions, space and time sees continuous flow, woven instead from discrete loops or information units. Falling matter is not crushed to an infinite point but rearranged into an extraordinarily complex informational structure within this labyrinth, retaining all data. This implies that, theoretically, mastering the labyrinth's rules could decode any ingested entity's past. November 2025's tentative primordial black hole detection bolsters this, as such relics mergers might preserve early universe information, testable via gravitational waves. The extreme contrasts in black hole activity have also been clarified. We know growth requires feeding. For instance, the black hole G2157, a nameless monster in the distant cosmos, is recorded ingesting a solar mass equivalent daily. A solar mass is the standard measure, about 330,000 Earth masses. Thus, G2157 consumes material equaling 1.3 million Earths each day. This approaches the maximum Eddington accretion rate, the upper limit before infalling matter's radiation pressure repels newcomers. Yet paradoxically, many supermassive black holes, despite masses in tens of billions of solar equivalents, exhibit unbelievable restraint. They may ingest only a few dozen solar masses yearly, akin to a cosmic giant nibbling a single grain of rice daily. Scientists confirmed this self-limitation stems from accretion-generated radiation. As matter heats to millions of degrees Kelvin just before the event horizon, it emits potent X-rays and gamma rays. These photons' pressure creates a counterforce on surrounding gas and dust, thrusting new matter away, curbing unbounded growth. The delicate balance between inward gravitational pull and outward radiation pressure dictates a black hole's growth fate. September 2025's Chandra findings of a black hole growing beyond normal limits challenge this balance, suggesting variable Eddington rates in certain environments. As we contextualize these discoveries within our own existence, their proximity and remoteness become evident. The nearest black hole, per updated 2025 estimates, lies about 1,600 light-years away, towards the constellation Ophiuchus. With humanity's current propulsion technology, reaching it would demand over 10 million years. Even our galaxy's central supermassive black hole, Sagittarius A star, 27,000 light-years distant, is an inconceivable span. Yet notably, our solar system seems miraculously shielded. We reside in the Milky Way's habitable zone, sufficiently distant from the chaotic core to evade frequent gamma-ray bursts or stellar disruptions near Sagittarius A star, yet not so remote as to lack heavy elements, essential for rocky planets and life, forged in prior stellar generations. The revelations of 2025, from destruction screams to cosmic murders, whirling waltzes, and ultimate quantum information decoding, lead to an irrefutable truth: black holes are not merely the extremist objects, the ultimate spacetime traps. They are physics' supreme laboratories, where classical gravity collides with quantum weirdness. Each observed ingestion, merger, or decoded oscillation not only peers into distant pasts but touches existence's foundational queries about time's nature, space's essence, information's endurance, and matter's being. This exploration of abysses, where reality bends to endurance's limits, has only truly commenced. And each new revelation paints a more intricate and fearsome cosmic portrait, one where shadows reveal the most light about creation's rules.